Okay, so you have trig identities, and the two major ones we're dealing with are quotient identity and Pythagorean. Okay, those are the only two you really need to have memorized as the way they are, because what you can always do is you can always rearrange them algebraically. So we'll start with the quotient one. Okay, so quotient one, the first set we have sine x divided by cos x is equal to tangent x. Okay. Well, with that being said, this could also be, if I bring cos to the other side, so if I were to bring cos to the other side, in order to do that, I'd have to multiply both sides by cosine x. Oh, I forgot my new circles. I'll just do this. Cos x. I know, oops. I'll draw a line for O's because it ends up circling here. Cos x. This cos x and this cos x cancel out, and it'd be tan times cos x. So in other words, another identity we can have is that sine x is equal to tangent x multiplied by cosine x. Okay? This is another, technically an identity. You could have this one memorized if you want. Another way to have this written, say we wanted to set it equal to cosine. Okay? So if we wanted to have it set equal to cosine, I would have to move tangent x over. Okay? And to move tangent x over, I would divide both sides by tan x and tan x. Okay? So this tan x and this x would cancel out. And we left with cosine x is equal to sine x over tangent. So in other words, it looks like this. Cosine x is also equal to sine x divided by tangent x. Okay? So that's the same identity, the quotient identity. We've just written it three different ways. So once you start to see these, it'll be easier to plug them in specifically. I know that I could actually just take sine and replace it with these two, or I could take cosine and replace it with these two. Same idea with Pythagorean. We'll do it on the right here, so it's easy to see together. The first one we have is cosine x equals 1. Now in the book they've written it for you, but I'm just going to show you. All it is this one rearranged. So let's say right now it's equal to 1, but let's say I wanted to make it equal to sine x squared. Well, to make it equal to sine x squared, this is positive cosine squared. When I move it to the other side, it becomes negative. So it becomes subtract cos. It's okay to do. So essentially it becomes
sine squared x equals 1 equals 1.
Okay, so like we were saying, when you bring cosine x to the other side, essentially it just becomes sine squared x is equal to 1 subtract cosine squared x, right? And the third identity they had in the book is the exact same idea, but if I wanted to move cosine x, sorry, I want to set it equal to cosine x, when I move sine x over, it subtract sine x, right? So the last one becomes cos squared x is equal to 1 subtract sine squared x. So really all of these identities, we have three different ones for each, are all exactly, all they are these original ones. We've just rearranged them. Okay, so we kind of get used to seeing stuff like that. So let's do your question 7D, was it? Is that the number?
Yep.
Okay. So 7.
6D.
Oh, sorry, 6. 6D. 6D for me. So the question said, verify each identity. So we had D. 1 subtract square theta. Now theta can just stand for x. X is any variable. Tan theta, cosine theta, and sine theta. Okay, so what this says is 1 subtract cosine squared theta equals tangent theta times cos theta times sine theta. Okay? So if we go ahead and take a look up here, where a lot of times what you'll notice they want you to do is they want to prove that the left side, they'll put this, left side equals right side. And what you can do is you can actually just focus on one side at a time. instead of always having to change both. So we're going to focus on the left side, okay?
How do you know which side to focus on?
It's really up to you. You choose one, aim for a target, and then kind of try to find that same target the other way. Sometimes you'll notice you'll go on one way, and when you're on the right-hand side, you'll notice that, oh, I don't need to go that far, or actually I need to go much farther than that. You'll start to get the hang of it. You'll start to see them. The more you do it, the more you'll see how they become equal. It's just dealing with the algebra, mixing it up back and forth, back and forth. It's a kind of a practice thing. So if I go to this, 1 subtract cos squared theta, check out my identities, doesn't work, doesn't work, doesn't work, doesn't work. This one right here, this is that exact expression. 1 subtract cosine theta is equal to sine squared theta. So perfect. I can replace that entire expression right there with just sine theta, right? Because we know it's equal to that. Sorry, well, sine squared theta. Make sure we get the square in there. So sine squared theta. So now I've dealt with the, I may not be done, but what at least I've done is I've simplified the left side. I just have one identity here, sine squared theta is equal to. Okay, and now let's go over to our left side identities. Well, we know that tangent is equal to sine divided by cos. So I could replace this with sine divided by cos. Or if we remember, tangent x times cos x. Now this is one they hadn't written in your book, right? But we rearranged it. Well, that's exactly what this says. This says tangent theta times cos theta is equal to sine theta. Okay? So I can just simply rearrange those two. I can replace them with, because they use theta, I say theta, sine x, right? So let's just replace that. So this tangent times cosine, I know that specifically is equal to sine. And I have to use whatever variable they use. They're using theta, right? So I've replaced that bracket now with sine theta, and I still have sine theta. Okay? Well, now I just have to carry out the math here. Sine squared theta, and sine theta times sine theta will be sine squared theta. Does that make sense?
Yeah.
Okay. Okay, question 7a. Now if you notice in this one, we have one squared identity, and then the other ones are not. Okay? So we either have to break down the squared identity into one that doesn't have that square, or we're going to have to turn these non-squared ones into a squared identity. Now when we quickly look to the top, nothing really says anything about that, switching a squared to a non-squared or vice versa, one that to the power of 1 to the power of 2. So let's just try to do a little math ourselves. What I'm going to do, because this is technically algebra, I'm just going to move the whole bottom part of this equation to the other side. And in order to do that, I'd have to multiply both sides. So in other words, this will show up on the other side. Okay, I'm not going to put the O because it just does that. It's going to be 1 plus cos x times 1 subtract cos x. Okay, so essentially we're setting up a FOIL question. So when I move that to the other side, it'll say sine squared x is equal to 1 plus cos x times 1 subtract cos x. Okay. Now this is FOIL. If you remember FOIL, we do the first terms, then we do outside terms, inside terms, and last terms, right? That's how we do the multiplication to it all. So you go along while I also do it, okay? See if you can kind of keep up. So first terms is 1 times 1, and the next term is 1 times negative cos, which is going to be negative cos x. The next terms I have positive cos times 1, which is going to be positive cos x. And finally, positive cos x times negative cos x is going to be negative cos squared x. Put it on the other side. I go to simplify. I have negative cos x plus positive cos x are going to cancel each other out. So I'm left with 1 subtract cos squared x. And now if we look at our trig identities from before, yeah, 1 subtract cos squared x is actually just equal to sine squared. So that this itself is a trig identity. But they might say, like your teacher might want you to break it down as basic as possible, because technically you can look here and go, I know those are equal, but they might say you have to prove that the left side is equal to the right side, in which case you then have to substitute in, well, this will be sine squared x, we know, and we know that this is sine squared x. Okay?
Mm-hmm.
Okay, this one's a little more difficult. We're dealing with tan squared, which we've never really dealt with before, right? So we're going to have to make some assumptions with some. The only identity we have that has a tan in it is our Pythagorean, our quotient. Okay, so our quotient one is sine x squared cos x squared. Sine x squared divided by cos x squared is tangent x squared. So I'm going to do a little calculation on the side. We know that tan equal to sine divided by cos. Okay. Now, this is any algebraic expression, so whatever you do to one side, I have to do the other. So in other words, if I decide to put plus 1 here, I'd have to also put plus 1 over here. They would still be equal, because I've added 1 to each side. So let's say I've decided, you could think of it almost like, let me do this one in red. If I had 2 to the power of, let's say 2, and it's equal to 4. We know those are equal in our head, right? Well, let's say I square both sides of the equation. So if I square this, when I go to square this by our exponent rules, this becomes 2 to the power of 4, and 4 squared. Well, 4 squared is 16, and 2 times 2 is 4 times 2 is 8 times 4 is 16 again. So as long as whatever I do to one side, I do to the other, it's fine. So for instance, that was our example if I squared both sides. So we know we have to create a tangent squared, obviously, from this, right? We've got to do some kind of tangent squared. So what I'm going to do is I'm going to square both sides of the equation and see what I get. So if I were to square tan x, it would be tan x times tan x, which can be rewritten as tan squared x. Okay. Now the only difference here is this then becomes sine x over cos x times sine x over cos x. Okay. In other words, what really ends up becoming is tan squared x is equal to, when we multiply fractions, top by top, bottom by bottom, we get sine squared x over cos squared x. Okay? So now what we can do is we can start working with these specifically. In fact, what I can do is I can, once again, now that I have my squared identity, you know what I'm going to personally do from looking at this? I personally think it's going to be easier. Right side. I think it's going to be easier if I work with specifically the right side of this equation. Okay? So I'm gonna work with just the right side, and I'm going to create a whole bunch of tangents. So, okay. So what I'm going to do now is, now we know we have tan squared is equal to sine squared over cos squared. I'm going to rearrange this equation so cos comes over. So I now know that sine squared x is equal to cos squared x times tangent squared x. So I'm going to replace this sine squared x. So I'm just going to say I'm dealing with the right side right now. Okay. So I can replace sine squared x with tangent squared times cos squared x. Okay. And I guess I can bring down the other side, tan squared x. 1 plus tan squared x. The other thing is, I know that if I once again rearrange this on this, here's our proof, right? Times tan squared is equal to sine squared. I know that if I have cosine, I can set cosine also equal to sine squared x over tangent squared x. So I could also replace the cosine if I want it with that sine over tangent, right? So really what we got to do is we got to start replacing these tangent squareds and 1 plus tangent squared x with these equations here. We're going to have to go into the second identity. Okay, so then we're going to solve this on the next video. So we'll call this part 2 of trig identities. Okay.